Hello everyone, welcome back. We're currently in lesson 15 where we're talking about derivative of trig functions, and in this video we're going to talk about derivatives of inverse trig functions. So before we get to the actual derivatives themselves, I want to derive one of them. So you guys can see here in the notes we do sine and tangent. I'm just going to show you guys how to do sine, and it's the same thing for the tangent one. But I want to derive this, and so what I want to do first is I want to set the inverse sine of x equal to theta, our angle, right? Because you guys have learned in previous math classes that you can rewrite the arcsine of x equals theta as the sine of theta equals x. These are equivalent to each other. This is what that means. So if you're trying to find what theta is, you can do the arcsine of x, right? So if I ask you guys to find the sine of theta equals 1/2, then you could absolutely go and do the sine inverse of 1/2, and that would give you pi over 6. So they are equivalent to each other, or the sine of pi over 6 equals 1/2. So they are equal to each other. So since they are equal to each other, I can now take the derivative of this implicitly, and then I will actually in turn get the derivative of this. So I want to go ahead and find the derivative implicitly, as I just said. So we're going to take the derivative of sine of theta, and we're going to get that that's going to be cosine of theta, and then it's going to be d theta dx. All right, so just implicitly, remember that we are still taking the derivative of our theta, and then everything's in terms of x, and then we're going to get the derivative of x, which is going to be 1, and then it's going to be dx over dx, right? Dx over dx. So which we all know is 1. So we can actually kind of drop that. So let's find d theta over dx. Well, that's just going to be equal to 1 over cosine of x. Well, we got to actually figure out what cosine of theta is by our little triangle over here. So one of the things that we need to do is see, well, sine of theta is equal to x. So if sine of theta is equal to x, that's understood to be x over 1, right? Because there's a 1 right here. So what we need to understand is from good old geometry, old school geometry, the sine is the opposite over the hypotenuse. So our good old friend SOHCAHTOA. So sine of theta is going to be the opposite side over the hypotenuse. And that's exactly how we mark 2 of our 3 sides of a triangle. Now, since this is a right triangle, we can use Pythagorean theorem to find this other side. So I'm going to go ahead and call this question mark. And so in order to solve this, I'm going to go 1 squared is equal to x squared plus question mark squared. So I can say, and I'm running out of room here, so going down here, 1 minus x squared is equal to question mark squared, right? So I'm just moving this all the way down here. And so question mark is going to be equal to the square root of 1 minus x squared. So now I can replace question mark with 1 minus x squared. And so now we're going to go back to here and say that delta x over, or delta theta over delta x is going to be equal to 1 over cosine of theta. Well, cosine of theta is going to be the adjacent side. So it's going to be the adjacent side over the hypotenuse, which essentially is just going to be, as you guys can see here now, it's just going to be 1 over the square root of 1 minus x squared. And so that is going to be the derivative, as you guys can see in the next problem down here. So it's 1 over the square root of 1 minus, now in this case, u squared, because now our theta is u. But just with the chain rule, you still have to multiply by the derivative of your theta. So one of the cool things about this that I want to show you guys is, first of all, everything that begins with the c. In the previous example, when we were talking about the derivative of our trig functions, they're all going to be negative. So all of them are negative. The other thing that's really cool about this is that the sine and the cosine have the exact same derivative, right? So the arcsine and arccosine have the exact same derivative. It's just that cosine ends up being the negative version of that. And if you went back up here and we did it with the cosine, you would get the exact same value, except for it would be negative in front. Another cool thing about this is that the tangent and the cotangent, you guys can see here, are also the exact, I'm going to go crazy with my highlighting, are also the same thing, right, with this. So the tangent and the cotangent have the exact same derivative. Again, the cotangent is going to be negative, And then the last one is that the cosecant and the secant also have the same ones. It's just, again, that the cosecant happens to be negative. And you can derive all of these problems, all of these based on the triangles themselves. So now let's actually find a derivative. So we're going to assume when I do these problems for you guys that you actually know these derivatives. And I'm going to call these derivatives skeletons because you guys will see that this is our foundation for what we need to do to find our derivatives. So let's actually do a couple of examples. All right, so I'm going to start with an easy one first. I'm actually going to go and do example number 3 first, and then we'll do a couple more of these in this lesson, and then we'll do another video with more detailed stuff. But what I need to show you guys is this. So we're going to look at question number 3 first. We want to find the derivative of arctangent of x squared. All right, so I went ahead and just put it on the next page here. All right, so first thing I want you guys to know is that we have to know what I call the skeleton. So what is the derivative of arctangent? So if you look at the previous page, it's going to be 1 over 1 plus u squared times the derivative of u. So this is going to be for tangent. If it's cotangent, you put a little negative here. So that's the first part of this problem, is just simply knowing, again, what I call the skeleton, which is really just the derivative of the arctangent, just the backbone for this. So your u is always going to be your theta. So that's pretty awesome. So when you're taking the arc of a trig function, your u will be what the theta is. So notice that in the equation that I want here, I need two things. I need a u squared, and I need the derivative of u. So the derivative of u is just simply going to be 2x. And I'll put a dx here, but you don't really need to do it for it. It's just 2x. And then the u squared is just going to be x squared squared. Once you've done that, so we have our skeleton, and now we have our u squared, and du, all we have left to do here is actually just substitute in. So this derivative is going to be equal to 1 over 1 plus u squared, well, u squared is x to the 4th, times the derivative of our function, which is 2u. So this derivative is going to be equal to our derivative is going to be equal to 2x over 1 plus x to the 4th. And that is all that you do. Now, that's the easiest way of doing the problem, right? There's a couple more complicated ones, but that's a general way of doing it. Write the skeleton down. You will always write u, du, and u squared, and then plug and chug. Plug and chug. All right, so now we have what the derivative for arctangent of x squared is. We're going to go up here and now do the derivative for arc cosine of x minus 1. So let's do that one next. So here it is, horribly written, but it is what it is. I know you guys already know this already, but you know the arc cosine of x minus 1 is the same thing as cosine to the negative 1 of x minus 1. All right, so to do cosine, we're going to write our skeleton out. And so we're going to be left with the negative 1, because again, cosine begins with a c, so we have a change of sign. 1 minus u squared times u prime. And so just like in the previous example, we're going to find out what u is. U is always our theta. Our du is just going to be equal to 1 dx. And then our u squared is going to be equal to x minus 1 squared. All right, x minus 1 squared. And usually for BC calculus, they want you to expand this. So this is x squared, multiply and double, and square the last. And now we have everything that we need. We have everything that we need just to plug in. So the derivative of arc cosine, or the inverse of cosine, is equal to, and so we're going to have negative 1 here. We're going to write the square root of 1 minus, and so we're subtracting this whole thing, right? So if I distribute a negative, I'm going to do minus x squared, minus the negative 2 is going to be plus a positive, and then minus 1 is going to be obviously minus 1. And then we're going to multiply this by our derivative. Well, in this case, it's just 1. So this is one of those times where we forgot to do this part. We actually looked up because it ends up being 1. And now we just need to simplify. So you can see that the 1's cancel out. So what's left beneath the square root is going to be negative x squared plus 2x. So the derivative of this problem is what you see right there. So again, ladies and gentlemen, skeleton, u squared, du, plug and chug, and then simplify as much as you can. Okay, so let's do one more example. So now we want to do a little bit more of one. So let's look at the arc sine of 1/2 x. All right, so arc sine of 1/2 x. Okay, so right here on our screen, we have the derivative of arc sine of x over 2, or the inverse sine of 1/2 x. They're all the same thing. And so in the previous two examples, we're going to write our skeleton out for sine. So it's exactly what you just saw for the cosine, except for this is going to be positive 1. And just like in the previous two examples, we're going to go ahead and write down what our u is, which again is our theta. Our derivative, it's easier to see it this way, written this way. We don't have to use the quotient rule, right? It's just going to be 1/2 dx. And our u squared, I think it's easier to see it this way. So it's going to be x squared over 4. Okay? So now we have everything that we need to do. So we can now find the derivative of our arc sine. And I'll write it a third way, right? The same thing with this. And so we're going to do 1 over the square root of 1 minus u squared, which is going to be x squared over 4, times our derivative, which is going to be 1/2. So this is a question that this is not the answer that you would see as multiple choice. This is not something you should leave as a free response question. You have a fraction instead of a fraction. So we're going to go ahead and simplify this down further and further until we get something that's pretty nice. So the first thing I'm going to do, and yes, I'm going to show every step here, is I'm going to go ahead and I'm going to combine my fractions underneath my radical. And so I get this. All right, so I'm going to go ahead and combine my fractions into one common fraction. So I get, if I were to split this back apart, I would get 1 minus x squared over 4. And then the next thing that I want to do in this problem is I want to now use my power of my exponents in my denominator and do this. Okay, so the square root of a over b is the same thing as the square root of a over b. Again, we're trying to get our fractions out, so we want to keep going with our problem. And so our next step is going to be 1 over the square root of 4 minus x squared all over 2. And remember that we're multiplying the top together, and we're multiplying the bottom together. So the 2's are actually going to cancel out. The 2's are actually going to cancel out, which means that our answer is going to be 1 over the square root of 4 minus x squared. So let's really quickly go back up here and see what we just did. So looking at our trig function, which being sine, we wrote our skeleton out. We wrote our u, our du, and our u squared, and then we immediately substituted into our formula. So we have our u squared is x squared minus 4 over 4, and then u is going to be 1 over 2. We see that we have a fraction inside of a fraction. We don't like that, so the first thing that I do is I combine my fraction underneath my radical. So I make 2 fractions into 1. Then I decide to split that and do the square root of the top divided by the square root of the bottom. I go ahead and say what the square root of 4 is. That just happens to be 2. And you guys can actually see it up here too, that the top 1 times 1 and the bottom, these are going to cancel. Those are going to cancel out, and then I'm left with 1 over the square root of 4 minus x squared. So does my trig function derivatives for arc, sine, tangent, whatever, always have a 1 in front of it? And the answer is no. It is no, and when we start integrating these things, coming up very soon, you guys will see us go back to the original for that problem. So that is the answer to that problem. So there you have it, ladies and gentlemen. We've done a pretty basic one, number 3. We did one where we had to just do a little bit of expansion and then distribute a negative. And then we did one where we have a fraction instead of a fraction. So those are your 3 journal cases that you guys are going to see with the problem. The example we're going to do in the next video is this one right here. It's actually really awesome what's going to happen with it. So if you guys want to come back to the next video, we're going to do a little bit more with derivative of inverses. And then we're going to start talking about how to rewrite inverses into polynomial form. So I'll see you guys back in the next video.